This is the second part of Lesson 28 in heat transfer. In this lesson, we will discuss how emissivity and absorptivity are related. By the end of this lesson, you should be able to explain, in your own words, the physical consequence of Kirchoffs Law. Kirchoffs Law is the law that says something about how the emissivity and the absorptivity are related. By the end of this lesson, you should also be able to explain and list the special conditions required to apply Kirchoffs Law to relate the spectral hemispherical emissivity and absorptivity of a surface. The consequence of Kirchoffs Law in this special case is that which will be used most often in this heat transfer class. On with the lesson.
Okay, Kirchoffs Law. So in ME 376, what Kirchoffs Law is going to say for you is that the spectral emissivity is always equal to the spectral absorptivity. Okay, there is technically some assumptions that have to be in place for this to be true, but and it's all related to the directional dependence of radiation, but we're not going to deal with directional dependence of radiation in 376. So you can just treat this as fact in here, all right? If you want to make a note to say that this only works if the incident radiation is diffuse, so this has to have diffuse irradiation and or diffuse surface. But we're always going to assume that that's the case in 376. If you want to see what to do when that's not the case, then again, take an advanced course in radiation. Okay, if you are interested, proof of the above is on pages 776 and 777 of the textbook. Or you have to typically, at least when I took my radiation course, it was a homework assignment to prove that. So, okay, makes sense? All right, now, there's also an important type of a surface called a gray. So this is Kirchoffs Law, this relation, this link between the two. There's a surface that we call a gray surface, and in a gray surface, the properties are constant. So those are linked by Kirchoffs Law, and in a gray surface, the spectral data is constant over all wavelengths. Right. So if the spectral emissivity and absorptivity is constant over all wavelengths, it's the same number, right? And you think about these definitions, it must mean, right, that the spectral absorptivity or the total emissivity and the total absorptivity must be equal. Okay, so therefore, alpha equals epsilon. This is not going to be the case if there is a wavelength dependence. So basically, gray surface means the emissivity is wavelength independent. That's the other important assumption, right, that we had for our equation, right? You know, this handles 90% of radiation problems equation, right? We needed to have a gray surface that's also, diffuse gray surface. So that's what we need. This has to be true in order for us to apply that equation. The properties have to be wavelength independent.